1% of America's farmland grows a quarter of its food. That's this valley. Flat, ordinary ground. The kind you'd sleep through on a highway drive. By every rule of geography, ground like this shouldn't be able to do what it does. It sits in a place where nothing should grow this well. Too dry for rain-fed farming, too flat to have built its own soil, walled off from the ocean air that usually makes farmland fertile. And yet drive through it in spring and you'll see more food growing per square mile than almost anywhere on Earth. The answer isn't luck, and it isn't modern engineering alone. It's buried underneath the dirt, 100 million years old, and it's the entire reason this valley exists the way it does at all. Look at a map of California and this valley barely announces itself. There's no coastline to draw the eye and no postcard mountain range, just a 500-mile trough running down the middle of the state, boxed in by the Sierra Nevada on one side and the Coast Ranges on the other. Most people flying over it don't look down twice, but almost everything that ends up on an American dinner plate has a decent chance of tracing back to this exact strip of ground. Almonds, tomatoes, grapes, cotton, dairy, rice, all grown here at a scale that doesn't exist almost anywhere else on the planet. California alone produces roughly 80% of the world's almonds, and most of that comes out of a handful of counties inside this valley. That's not a boutique specialty crop. That's a fixture of global agriculture, sitting on ground that, on paper, should not support it. None of that squares with the climate. This valley sits in what's called a rain shadow. The Sierra Nevada wrings most of the moisture out of incoming storms before they ever reach the valley floor, and the Coast Ranges block what little marine air might soften things from the west. By the normal rules of climate and geography, this should be a dry, thin-soiled basin, closer to scrubland than farmland. Instead, it's some of the most productive agricultural ground on Earth. So the real question isn't why California grows a lot of food. It's why this specific place, flat, dry, hemmed in by mountains, missing almost every ingredient a fertile region is supposed to have, became the exception. Farmers didn't build this valley's fertility from nothing. They inherited it. Something underneath the surface did the actual work, long before anyone plowed a single field here. And it's not a story about rainfall or irrigation canals. It's a story about what this ground used to be, tens of millions of years before it was ever a valley at all. What's actually underneath this valley is a 100-million-year collision. For roughly that long, the floor of the Pacific Ocean has been shoving straight into California and losing one slab of crust forced down and under the other, a process geologists call subduction. That collision built this whole stretch of land the same way collisions like it always do. Volcanoes rose inland where the sinking plate melted at depth. A mountain range got thrown up along the coast where rock got scraped and folded. And in between the two, the ground dropped, a long trough that caught everything eroding off both sides. That trough is this valley. Geologists call it the Great Valley Forearc Basin, and it's been collecting sediment continuously since roughly the Cretaceous period, the age of the dinosaurs, when this stretch of California sat underwater as part of a shallow sea along the Pacific margin. That's not a metaphor. The floor of this valley, in a very literal sense, used to be seafloor. Marine sediment settled here for tens of millions of years, layer after layer, while the Sierra Nevada rose to the east and the Coast Ranges rose to the west, slowly closing the trough in on both sides like a vise. Then the sediment kept coming, but the source changed. As the Sierra Nevada pushed upward, rivers began carrying eroded granite, volcanic ash, and glacial debris down from the mountains and dumping it onto the old seafloor. Over millions of years, this built up an almost unbelievable depth of material. Drill down almost anywhere in the northern part of the valley, and you won't hit solid bedrock for roughly 5 miles, according to geologic borehole and seismic survey data. Almost none of that material is visible from the surface. What you're driving across is the very top of a sediment pile that goes down miles, built from two completely different sources: an ancient ocean floor on the bottom and a young, actively eroding mountain range on top. This is the part almost nobody driving through the valley ever thinks about. The ground under a strawberry field near Fresno or an almond orchard outside Modesto isn't just dirt. It's the compressed, buried remnant of a Cretaceous sea capped by millions of years of mountain runoff. The valley didn't get fertile by accident, and it didn't get fertile recently. It's been quietly manufacturing the raw material for that fertility for longer than there have been mountains standing on either side of it. The next question is how 100 million years of buried ocean floor and eroded granite actually turns into some of the richest farm soil on the planet. Before any of that soil got turned into farmland, a huge part of this valley wasn't land at all. Through most of the last ice age and into the 1800s, the southern end of the valley held Tulare Lake. At its peak, roughly 790 square miles of open freshwater, making it the largest freshwater lake west of the Mississippi River. It was big enough that 19th century steamboats ran cargo across it. Then, between the 1870s and the 1920s, it disappeared. Not through drought, through agriculture. Settlers diverted the rivers that fed the lake into irrigation canals, and within a few decades, one of the largest lakes in the American West simply stopped existing. The lake bed became some of the most productive farmland in the valley, planted over as if the lake had never been there at all. For about 100 years, that's exactly how most people treated it, as history, not geography. Then in March of 2023, after an unusually intense series of storms, Tulare Lake came back. Roughly 94,000 acres of farmland disappeared underwater again, in some places for over a year, as the old lake bed did exactly what lake beds do when the water shows back up. It filled in. Farms that had operated for generations on reclaimed land were suddenly underwater again, and satellite images of the reappeared lake circulated widely, showing a shape almost identical to the historical lake boundary. Stories like that are exactly why ordinary-looking ground is worth a second look, and it's exactly the kind of thing this channel digs into. If that's your kind of curiosity, subscribing means you won't miss the next one. It's a strange kind of proof. The lake wasn't erased by geology, it was erased by people for a little over a century, and geology simply waited. That pattern matters because everything else this valley is built on, the buried ocean floor, the eroded mountains, the soil piling up on top of both, is the same kind of patient physical process. None of this ground needed permission. It simply kept doing what geology does, which raises the real payoff question. How does an ancient buried sea actually become some of the best farm soil on the planet? Start with the ingredients. 3 different processes have been dumping raw material into this valley for millions of years, and each one contributes something a farmer would otherwise have to add by hand. The first is the Sierra Nevada itself. As that range has risen and eroded, rivers have carried down enormous quantities of ground-up granite, rock rich in minerals like potassium and phosphorus that plants need to grow. That's not topsoil in the traditional sense. It's pulverized mountain delivered fresh by rivers for millions of years running. The second is volcanic ash. The Sierra Nevada and the broader region have a long history of volcanic activity, and ash from those eruptions has repeatedly settled across the valley floor. Volcanic ash weathers into some of the more fertile soil on the planet. It's the same reason volcanic regions elsewhere, like Italy's Mount Vesuvius farmland and Indonesia's Java, are known for productive agriculture. Different ash, same basic chemistry. This valley got its own version of that treatment layered in over geologic time. The third is glacial outwash, sand and gravel washed down from melting glaciers. During past ice ages, glaciers in the Sierra Nevada ground rock into extremely fine sediment, and meltwater carried that material into the valley and spread it out in broad, flat layers, a large part of why the valley floor is so level to begin with. Flat ground, it turns out, isn't a coincidence. It's a byproduct of the exact same erosional processes that made the soil fertile in the first place. Layer those three sources, eroded granite, volcanic ash, and glacial silt, on top of tens of millions of years of buried marine sediment, and you get something close to a perfect natural fertilizer, applied continuously since before humans existed. Add California's Mediterranean climate with mild wet winters and long sun-drenched growing seasons, and Sierra snowmelt that functions as a natural gradual irrigation system every spring. And the paradox from the start of this video starts to make sense. This valley isn't fertile despite being flat, dry, and boxed in by mountains. It's fertile because of the specific combination of everything those mountains have been feeding into it for 100 million years. 1% of America's farmland growing a quarter of its food isn't a miracle. It's simple physical accounting. Geology depositing exactly the right ingredients in exactly the right place for 100 million years straight. Put the whole sequence together, and this is what actually happened. 100 million years ago, this strip of California was open ocean, a shallow sea along the Pacific margin, quietly accumulating marine sediment on the seafloor for tens of millions of years. As the Sierra Nevada and Coast Ranges rose up on either side, that ancient seafloor got trapped between them, sealed into a structural trough geologists call the Great Valley Forearc Basin. Then, for millions of years after that, erosion off the rising Sierra Nevada, ground granite, volcanic ash, glacial silt poured down on top of the buried ocean floor, layer after layer, building the flat, fertile valley floor that exists today. That is the actual answer to the question this video opened with. This land isn't fertile because of anything modern humans did to it. It's fertile because it spent 100 million years as the collection point for two of the richest natural soil building processes on the planet, an ancient sea on the bottom and an actively eroding mountain range on top, stacked one atop the other for longer than the mountains around it have even existed in their current form. And that's why the paradox resolves the way it does. 1% of America's farmland growing a quarter of its food isn't an accident, and it isn't purely a triumph of irrigation engineering, even though the canals and aqueducts built here in the 20th century clearly matter. The deeper truth is that this valley was always going to be exceptional ground. The moment the Sierra Nevada started rising and dumping mountain-grade fertilizer onto an already mineral-rich, buried seafloor. Humans arrived millions of years into a process that had already done most of the work. What farmers really did was uncover what was already there and figure out how to water it reliably. It also answers the question this whole video opened with: why a flat, ordinary-looking strip of farmland looks like it shouldn't exist at all. On paper, this climate was never supposed to support farmland at this scale, but it does, and it thrives, because underneath the ordinary surface is 100 million year record of exactly the right raw materials landing in exactly the right place, over and over, for longer than almost anything else in this part of California has been forming. The valley didn't beat the odds. It's what happens when an ancient ocean and a young mountain range spend 100 million years depositing everything a farmer could ever ask for onto the same patch of ground before a single seed goes into it. There's a cost to all of this too, and it deserves an honest accounting. Farmers have pulled the same water up from underground for over a century, faster than it can naturally refill. Groundwater overpumping has caused parts of the valley to sink, a process called subsidence. Near the town of Mendota, a geologist named Joseph Poland documented it with one of the more striking photographs in American earth science, a utility pole with markers showing the ground level in 1925, 1955, and 1977. Between those years, the land sank roughly 29 feet. Other areas like Corcoran have sunk more than 13 feet since the 1960s alone, and repairing infrastructure like the Friant-Kern Canal, damaged by that sinking ground, has cost hundreds of millions of dollars. That's not a reason to see this valley as fragile or doomed. It's the honest price of asking exceptional ground to do exceptional work, decade after decade, without always giving back what's been taken. The same forces that spent 100 million years building this place are still active underneath it. Now people are part of that story too. Next time you're eating an almond, a tomato, or anything with a grown in California label, there's a decent chance it came from this exact patch of ground. Flat, easy to overlook, and sitting on top of one of the more improbable geological stories in the country. If there's a stretch of ground near you that looks too ordinary to have a story like this behind it, tell me where. That's usually where the next one turns up.